Malaria is the greatest single-agent killer of children on the planet, bar none. And it's been doing it from time immemorial. So for the last 20,000 years of coevolution with humans, 10,000 children a week or more have died of malaria. It's really an unstoppable culling machine. Malaria's got a complex genome. It has lots of genetic tools to bring to bear in its task, which is to evade your immune system and to multiply as much as possible without killing its host. We have an unbelievably dedicated group of individuals spread out all over the world. So there's about 15 or 20 individuals working at Brown and its affiliated hospitals. We have teams in Kenya, partners from NIH and their field site in Tanzania. Without the field science, our approach doesn't exist. We start with humans. That's our niche. We start in humans. We try to figure out why humans are resistant. And by trying to figure out what's different in the antibody repertoire of the resistant and the susceptible kids, we were able to discover GARP. PF-GARP is a protein that the parasite makes on the surface of the red cell for sensing host illness. If the host gets too ill, GARP gets activated, and that shuts down parasite replication. When antibodies bind to GARP, they cause the parasite to die. We're going to take three approaches to capitalize on this discovery. The first will be a straightforward vaccine approach, where we immunize with GARP and the individual generates anti-GARP antibodies that will trigger cell suicide for the parasite. Another approach is we can make monoclonal antibodies in great quantities. We'll take a therapeutic approach where we infuse GARP antibodies and they either kill parasites that are in the person or they'll protect that person for up to 3 months from getting infected. So the antibody could be therapeutic or prophylactic. And lastly, whatever the antibody is doing when it binds to GARP, that's druggable. If we could find a small molecule that mimics the binding of antibody to GARP, we'll have discovered a whole new class of anti-malarial drugs. We brought it through the laboratory studies, the tissue culture studies, all the way through non-human primates. The next step is a phase 1 study in humans, and that's where you actually, for the very first time, immunize humans with GARP protein. You see if it's safe, and you see if it's effective. If we're able to generalize the vaccine results we've seen in monkeys to humans, even if we don't improve upon it, we will have cut the under 5 mortality rate due to malaria in half. I am phenomenally grateful to all of the partners that we have who have helped make this happen. Colleagues from NYU, colleagues from Harvard, colleagues from Yale, colleagues from Florida Atlantic, colleagues overseas. Without them, none of this could possibly happen. This began as an interaction between Patrick Duffy, Michal Fried, and myself, using samples from their Tanzanian cohort to identify new vaccine candidates. To see it finally coming together, after almost a decade of work, has been really incredibly exciting. And to actually imagine this might be part of a vaccine that's effective against literally the greatest killer of children on the planet. You would no longer have to worry that a quarter of your children are going to die from malaria. You would no longer have to worry that you were going to have to sell the few livestock that you have to pay for your children's health care costs. You would no longer have to worry that you were going to be so anemic you wouldn't be able to plow your fields. It would completely change society.